Assalamu alaikum ji. We will start the second lecture from what is software. So software is computer programs and associated documentation, such as we gather the requirements, and when we design some models, we create some models in the form of designs based on the requirements of the system, and then we create how to use. Then we have the user manuals that how to use that particular software. This collection of computer programs and its associated documentation, we call it as a software. This is actually a software. In simple words, we can say that set of instructions that are grouped together or joined together to create to perform a particular task is called as software. But in more specific language, we say that computer programs, obviously they are the set of instructions along with the associated documentations, and the basic documentations are the requirements, design models, and user manuals. When we join together, so we say this is actually creation of the software, or this is called something as software. Software product may be developed for a particular customer, or may be developed for a general market. We can create software for a particular customer, or it can be developed for a general market. If the software is created for a general market, then we call that software as a generic software. We say that this software is a generic software. And when we create the software for a specific customer, so we say this is customized software. Depends on what type of requirements are coming out of the customer, depends on either there is a single customer or there is a general community. If, for example, the case of the generic software is your Microsoft Office, MS Word, or MS Excel, that is not created for a single customer, that is created for the whole community. So we will say that they are having actually the general requirements of the system. So we call those software as generic software. Generic means that it is available for everybody. This is a public sort of software. The second type of the software is your customized software, which we call custom software, or in books you will see that bespoke software. Bespoke, custom, or customized software, these are developed for a single customer according to their specification, or for an organization according to their specification. So we call this type of the software as a custom software. And new softwares can be created by developing new programs. Obviously, if you want to create a new software, then you can create it by using new programs, or you can configure a generic software to be used as a new software. The famous example is your MS Excel. So MS Excel is used in shop for selling products. The same MS Excel is used at your examination within your department as a software to print your DMC. So generic software can be configured, can be customized to work as a custom software, but custom software cannot be generalized. This is a big process to make a customized software as a general software, but generalized software or generic software can be customized. And generic configuring generic software systems or reusing the existing software, you can create a software product that can be generic or that can be customized. So this is general discussion about software. So actually software is a computer program, and the associated documentation required for that particular software. This process is known as creating a software. And the software, then we have discussed about the categories of the software, and generally we can categorize software into two categories. The first one is your generic software, the second one is your customized software. In generic software, the softwares are created for the general community. In custom software, the softwares are created for a specific customer or a group of specific customers. We have already discussed software engineering. This is an engineering discipline that is concerned with all aspects of software production. Aspects of software is your extracting requirements of the customer. Whenever a customer come to you and he wants to create a software, like for example a calculator, so the person asks you to create a calculator. The person who is asking you to create a calculator is actually the customer. He will provide you the requirement. He will say to you that I want to create a calculator for addition, subtraction, and multiplication. Now, these are what? These are the requirements of the customer. Being a software engineer or software engineering individual, so you will be concerned with the development of this software production, software. Whatever the aspects are, the first aspect of the software development is extracting requirement from the customer. What the customer wants. Actually, what the customer wants is actually the problem of the customer. He wants it to be solved by you through a software. What the customer wants will eventually become requirements of the system. They will become the requirements of the system. And when you extract requirement, you understand the problem, you create the design for that particular software. After making the design, you implement that software, you create code for that software. These all aspects, starting from requirement, going to the design, and then creating code for the software, these all aspects are involved in the development process of the software. This development process of the software, in which all the aspects are covered, this whole process is actually called as software engineering. And here, software engineers should adopt a systematic and organized approach to their work and use appropriate tools and techniques depending on the problem to be solved and the development constraints and the resources available. Now, here the task of the software engineer is what? The task of the software engineer is to adopt a systematic and organized approach. Now, what is systematic and organized approach? Systematic and organized approach is actually follow a particular process model. We will discuss later on what is a process model. Follow a set of activities. We will discuss what is set of activities. I will discuss right now the three set of activities. One was requirement, the second was design, and third was implementation. Now, if you use it in a systematic, in a procedural manner, first you have to understand the problem of the customer. That will give you the requirements of the system. Then you have to create design of the system. Then you will go towards implementation of the system. This is systematic and organized approach. About what? About work. Work is what? Creation of the software. Once requirements are clear, design is understood, now you are in a position to apply a appropriate tool or technique, whether it can be a procedural technique or it can be an object oriented approach. It can be a web-based application, it can be a desktop-based application. It totally depends on what problem you are going to solve. Either you are solving a desktop-based application, or you are trying to solve a web-based application, or you are trying to solve an application which requires procedural language, or you are trying to solve an application or a problem which requires object-oriented approach. Obviously, when you select the tool, definitely the development constraints applies on you. Like for example, I create int I, integer I. So I do know integer I size is 2 bytes. It can hold maximum as a particular value, but I cannot hold a floating point value in integer variable. Now this is what this is development constraint. Similar like other constraints. If you miss omit, if a statement is complete and you do not put a semicolon, this is development constraint. Plus the resources available. Your laptop is a resource, your electricity is a resource, your software application is a resource. If resources are available, the development constraints are defined, problem is present which needs to be solved, you have selected the appropriate tool and technique, you have applied an organized and systematic approach. This whole process is adopted by software engineer to create a professional software. And this whole complete procedure is known as software engineering. Then we will come towards the difference between software engineering and computer science. Software engineering is totally practical approach. The practical applicability of the practical aspect of the software development is done by software engineer, whereas computer science provides you the theory. The information part is provided to you by computer science. So computer science is concerned with theory and fundamentals, whereas software engineering is concerned with the practicalities of developing and delivering useful software. Theory will be provided to you by computer science, and practical approach, that is extracting requirement, creating design, implementation, that will be given to you by software engineering. Yes, we have problem in terms of the theories of computer science. Computer science theories are still insufficient to act as complete underpinning. Underpinning means foundation. We call it in Urdu as bunyad, foundation for software engineers. Yeah, software engineering. Because in physics, we have a concrete foundation. E is equal to mc square, equation of Einstein's equation is equal to mc square. Yeah, speed of light, that is defined, that is definite. G value is definite. G is equal to 9.8 meter per second square. That is complete foundation. If you draw something or if you create something based on speed of light, that is c constant, or the gravitational force, you have got a solid foundation. But this is not the case with computer science theory. It is changing with every day. Few years back, I had Android version 2. Now I am having Android version 11 or 12 or 13. Theory is changing about the computer science. If theory is changing, it means my foundation is not as much valid or as much solid as it is in physics or other electrical engineering departments. So we say there is a flaw, there is deficiency in terms of complete foundations available in terms of computer science knowledge, but still there is a capacity to create a professional software if the existing knowledge of the computer science theories are applied. So this is a basic difference between software engineering and computer science. Software engineering deals with the practical approach. Computer science will provide you the theoretical information. What is the difference between software engineering and system engineering? So we have discussed software engineering. We will discuss system engineering is concerned with all aspects of computer-based systems development, including hardware, software, and process engineering. Process engineering is actually manufacturing, so that is not part of our engineering process, but it is a manufacturing engineering. Two things are involved, hardware and software. We combine together or group together, we say we are creating it, we are performing actually system engineering. And one of the part of the system engineering is software. One of the problems solved by the system engineer is solve software, and the software problem is solved by software engineering. Software engineering will solve this part out of the system engineering. System engineering is concerned with development of the hardware, development of the software, and the process engineering. Whereas software engineering is part of the system engineering. Software engineering is the part of the system engineering in which it is only concerned with the development of the software. It will only create the software infrastructure, control aspects of the software, application, and database in the system. When we say system engineering, actually we are talking about whole computer system. So in a whole computer system, we have got two common things. One is the hardware and other one is the software. So system engineering deals with hardware development of the hardware, development of the software. Where software engineering, it is only concerned with the development of the software, which is part of the system engineering. So system engineers are involved in system specification. System specification are the requirements of the system. Here system means whole computer system. Here system means whole computer system. That is hardware and combination of the hardware and the software. Then we will go towards the architectural design, the decomposition of the system. As I've given you the example of the calculator, so calculator is divided into three parts. For example, addition, subtraction, and multiplication. This division of the calculator into subparts, this approach is called as, or this method is called as architectural design. We will discuss further in coming lectures about architectural design or system specification. The decomposed individual subsystems are easy to develop. Then we integrate them. Integrate means we combine them. I've created calculator. I've created calculator in three subparts: addition, subtraction, and multiplication. When I create addition and subtraction, I group them, I combine them. This combination is called as integration. When I create the multiplication, I combine it with addition, subtraction, and multiplication. This whole process is system integration. Now I'm in a position to deploy that particular software, which is called as calculator. So deployment means installation of that software at the customer computer. This process is known as deployment. This is the task of the system engineer to perform. He is involved in system specification, requirement of the system in terms of hardware requirement, in terms of software requirement. He is involved in architectural design. He is involved in integration, and he is involved in deployment. Understand? So there are the difference. Software engineering is part of the system engineering, in which it deals with the creation of the software. So we have discussed about software engineering and computer science. We have discussed the difference between software engineering and system engineering. Now we will talk about software process. A set of activities whose goal is the development or evolution of software. There are set of activities, like I have told you: requirement, understanding requirements, creating requirements, generating requirements, then according to those requirements, creating a design, and then after creating a design, you are implementing that software. These are three activities: requirement, design, and implementation. When we combine them, we say these are set of activities. The set of activities whose ultimate target or goal or objective is to develop a software or to evolve a software. Development and evolution are two different things. Development means you're creating a new software. Development means you are using existing software. Evolution means there are some problems associated with the current software. You are trying to remove those problems from the existing software. We say software is evolved. The process is evolution process. The set of activities whose goal is the development or evolution of the software, we will call it as software process. The generic activities involved in all software processes are: first one is specification. At this moment, you can consider specification as requirements. Second one is development, production of the software system, that is coding of the system. Validation, check your code according to the specification. Whatever you have developed, check it according to the specification. That is, check it according to the requirements of the system. Then validation, and then last but not least, that is evolution, changing the software in response to changing demand. There is problem, there is a change required. This change will be accommodated. This process is called as evolution. So there are four generic activities involved in software process. The set of activity is specification. These are the set of activities: specification, development, validation, and evolution. This set of activity whose ultimate goal is the development or evolution of a software, this is called as software process. Then we have software process model. The set of activities shown in the previous slide, if they are organized in a particular way, in a specific way, in an organized manner, this layout, this structuring, we will call it as software process model. Or in definition point of view, from the definition point of view, a simplified representation of a software process. What is software process? That is set of activities whose ultimate goal is the development of the software, presented from a particular or specific perspective. That perspective can be workflow perspective. We will discuss what is workflow. Normally, workflow perspective is your requirement, then design, then implementation. This is sequence of activities. This perspective is called as workflow perspective. Second one is data flow perspective, which is information flow. In database, you will study ER diagram. That is data flow diagram. That data flow diagram is actually data flow perspective. We will not be studying data flow or role action perspective in software engineering one. We are focused on workflow perspective, that is sequence of activities already defined in the set of the activities that is a specification, development, validation, and deployment. Those sequence and are organized in a particular sequence in which requirement and design will come in one phase, or requirement will come first, then design, and then implementation, and then deployment. This is one organization. Second set of sequence of activity will be requirement and design are in one phase, implementation in second phase, and deployment in third phase. This is second sequence of activity. This arrangement of the set of activities in a specific order is called as software process model. This arrangement of the software process in a particular way from a given perspective, for a given or a specific perspective, is known as software process model. So I hope it will be clear up till this, and if it is not clear, you have got questions, you can post your questions on in the WhatsApp group, and I will be available. I will be there to answer your questions. So thank you very much.